What if we could hack the planet? No, I mean really hack it. What if we could actually reach up into the sky and deliberately tweak the Earth's atmosphere, kind of like turning down the thermostat on your air conditioner? It sounds like something straight out of science fiction, right? Well, this idea, it's real, and it's one of the most audacious and honestly controversial proposals of our time.
And that brings us to the huge question we're tackling today. Could we, and maybe more importantly, should we, deliberately engineer our own climate to fight climate change? You know, this isn't just some fringe theory anymore. This group of technologies, known as solar geoengineering, is moving from the lab right into the halls of power.
So, here's how we're going to break it all down. First up, what is this planet-sized idea anyway? Then we'll get into why it's being considered a response of last resort. After that, we'll look at the nuts and bolts of how you'd actually, well, dim the sun. Then comes the really heavy part. Is this a cure or is it a curse? And all of that leads to the final, critical question. Who gets to control the thermostat for the entire world?
All right, let's dive into our first section. Before we get any further, we gotta get on the same page. When we say hack the planet, what are we really talking about?
The big, broad term is geoengineering. The Royal Society defines it as the deliberate, large-scale manipulation of our planetary environment. The whole goal? To counteract climate change. Just think about that for a second. This isn't some accident. We're talking about a massive, intentional intervention in the planet's most basic systems.
Now, within that huge category, we're going to zoom in on one really specific and really controversial idea: solar radiation modification, or SRM for short. So instead of trying to remove greenhouse gases, the root cause, SRM aims to treat the symptom, which is the heat itself. The plan, in theory, is surprisingly simple. Just reflect a tiny bit of sunlight back into space before it can warm us up.
And this right here shows you the fundamental split. On one side, you've got carbon dioxide removal, which is all about trying to cure the disease by literally sucking CO2 out of the air. And on the other side, you have SRM. And this is the most important thing to remember. SRM is like a planetary painkiller. It masks the fever, but it does absolutely nothing to stop the infection. All that rising CO2 that's causing the problem in the first place.
Okay, so if SRM is just a temporary fix, a painkiller at best, then why is this incredibly risky idea even on the table? Why are serious people actually talking about it?
The answer, in one word, is pretty much desperation. Our global efforts to cut emissions, well, they just aren't keeping pace. We're on track to blow right past our Paris Agreement targets, and as the planet keeps heating up, as the fires and floods get worse and worse, some scientists are looking at this radical idea not as a first choice, but as a last-ditch emergency brake.
And that painkiller analogy is really key to understanding the argument for SRM. Proponents will tell you it wouldn't fix the underlying problem, but what it could do is buy us something incredibly valuable: time. Time to get our emissions under control, time to transition our economies, all while hopefully holding off the most catastrophic heat waves and storms.
So, how would you actually do this? I mean, how in the world do you dim the sun? Turns out, there are a few pretty wild ideas on the drawing board.
This chart kind of lays out the main contenders. You've got everything from brightening clouds over the ocean to, yep, you're reading that right, giant mirrors in space. But the one that gets the most attention by far, the one we really need to understand, is that first one, stratospheric aerosol injection, or SAI. So let's focus there.
And the inspiration for SAI is pretty amazing. It comes straight from nature. You might remember the eruption of Mount Pinatubo back in 1991. It blasted this massive cloud of sulfur dioxide way up into the stratosphere. And that cloud created a planetary sunshade, a sort of reflective haze that cooled the entire globe by about 0.5 degrees Celsius for over a year. So SAI is basically our attempt to bottle that volcanic effect and release it on command.
So here's the theoretical playbook. You'd use a fleet of special high-altitude jets or maybe balloons to spray a fine mist of these reflective particles high up in the stratosphere. These particles would then create this thin, basically invisible shield that bounces a little bit of sunlight back to space, cooling the planet down below. But, and this is a huge but, these particles don't stay up there forever. To keep that cooling effect going, you'd have to keep spraying, continuously, maybe for decades or even centuries. Mimicking a volcano? It sounds almost elegant, doesn't it? But messing with the planet's climate system on this scale, well, that opens a Pandora's box of profound risks. And this brings us to the core of the whole debate. Is this a cure for our climate fever, or is it a curse with its own catastrophic side effects?
So here it is, the fundamental, inescapable flaw. Solar geoengineering does nothing, zero, about the root cause. While we're busy dimming the sun, CO2 would just keep piling up in the atmosphere. That means the oceans would continue to get more and more acidic, threatening all marine life. A whole host of other climate impacts would just keep getting worse, completely untouched by our solar shield.
And the list of what could go wrong is, well, it's terrifying. We're not just talking about minor side effects. Climate models warned that SAI could rip a hole in the ozone layer. It could trigger acid rain. And most alarmingly, it could throw global weather patterns into total chaos. Can you imagine tinkering with the monsoon rains that billions of people depend on for their food and water? You could accidentally trigger devastating droughts in one part of the world and catastrophic floods in another.
And these risks aren't just abstract theories. One study, for instance, looked at the impact on just a single crop, groundnuts in India. The model predicted that under a geoengineered sky, yields could plummet by as much as 20%. That's a massive potential blow to a food source for millions of people.
Okay, now scale that one example up. Some models predict that by messing with the monsoons in Africa and Asia, a geoengineering program could put the food and water for up to 2 billion people at risk. Just let that number sink in. 2 billion. The potential human cost is just almost impossible to comprehend.
But maybe the most terrifying risk of all has a fittingly terrifying name: termination shock. Picture this nightmare scenario. We deploy SRM for 100 years. Underneath our artificial shield, greenhouse gases just keep climbing higher and higher. Then something breaks, a war, an economic collapse, a technical failure, and the system just stops. All of that mass warming that's been building up would be unleashed on the planet all at once. The temperature spike would be so fast, so brutal, that adapting would be impossible. It would be planetary whiplash on a catastrophic scale.
And that leads us to the final challenge. And this one might be even harder to solve than the science. The environmental risks are huge, for sure. But the politics might just be impossible.
Just think about it for a second. Who gets to push the button? Who gets to decide the planet's temperature? A setting that might be perfect for Canada could trigger a famine in India. And what happens if one country just decides to go for it on their own? What can anyone else do? And eventually someone is going to ask, could this be used as a weapon? Right now, for all of these planet-altering questions, we have zero answers. No laws, no treaties, no one in charge.
And that's really the razor's edge we're on. Is solar geoengineering a vital emergency brake that we absolutely need to have in our back pocket just in case? Or is it a geopolitical time bomb, a cure that's far, far worse than the disease? We don't have the answers yet, and this whole debate is really only just getting started.